All right. Well, we're going to try this method again with the more powerful hydrogen peroxide. 12%. All right. Well, I've gone and incinerated all these bad boys. Not a whole bunch of them. Let's see. And we got them all. Perfect. We're going to start with putting a little bit of hydrogen peroxide in here. Brand new. Got to get the, hold on. Hold on. All right. Let's see. We're just going to go like this with a quick, there it is. Pop that off of there. We don't need any of that. There we go. Get that out of there. Throw it in the garbage. Alright. So we're going to go ahead and start with some hydrogen peroxide. This looks like a tablespoon. Tablespoon of salt. And 2 tablespoons of citric acid. Alright, we're going to give this a good stir. See what we're left with. We may need to add a little more hydrogen peroxide. So I was testing it with distilled water, but I think the other 88% of this is going to be distilled water. So we should have plenty in there for the metals to go. Let's see, top that off a little bit. We can already see the color changing. Picking up that blue haze. And these are all my thin ones. The contacts, the fairly small contacts with the thin base metal surrounding. I saved the thick ones for my anodes because it's too much. It's too much base metal for this, and you got to babysit it way too much. So, all right. Well, I'm going to come check on this here in a little bit. Make sure that we don't have any crystals on the bottom. If we have more crystals on the bottom, I'll go ahead and add more hydrogen peroxide. All right. I'll keep you posted. All right. Just a quick vid of the reaction that takes place in there. Very nice. Wow! I was not expecting that. So, we had quite the boil over. I can't believe it. From hydrogen peroxide, citric acid, and salt. Crazy. Alright, well, I almost want to do that again and record it. That's crazy to me. Alright, well, let's see. Yeah, we still got quite a ways to go. What a reaction. What a reaction. So here's some of the carnage. Look at that. Crazy. All right. So, learned my lesson now. We're going to try that. We're going to try half the amount of stuff. And we're going to put a top on it, and we're going to put it in a catch pan because I had no idea. We didn't even get anything close to that kind of reaction with the 3%. It's pretty potent stuff. Pretty potent stuff. So I'm actually going to dump this out here so we can start over from scratch. I'm also going to save this solution, well, the most of it, because somebody was curious on how I can make that safe by getting that that copper out. So we'll see if we can plate it out or if we can plate iron out just like we would with all of our other stuff. So let's try that again. Doesn't look like I had too much stuff left over, meaning salt and citric acid. So let me grab that stuff out again. Let's see here. And I'm going to grab a smaller spoon this time. Okay. We're just going to work our way down. So we're going to do a teaspoon of that. Two teaspoons of citric. And we're going to break out the hydrogen peroxide here. There it is. Give this a good stir. Yeah, I had absolutely no idea that that was going to happen. So I'm going to monitor this a little more thoroughly this go around, because that was quite the... Man, I really wish I had it recorded. That would have been hilarious. Well, we might get it to repeat it again. So I did make it a little smaller. I want to capture that. I want to see what happens, and I want to see if... like temperatures, I want to see exactly what's going on with that and why that happens. So I know I cut it down a little bit. Well, one way to test it, right? Let's see if we can get it to repeat that process. And yeah, wild. So we're at what, 66.2, 90 degrees Celsius. See what happens here. So we are getting a little warmer, 68. It's been about 3 minutes. Oh yeah. This isn't on heat, right? This is just on my tabletop. There's quite a reaction that occurs here. It's, man, this stuff is so interesting. All right, so we're about 10 minutes into the this experiment here. 75. Okay, so it's going up. Not nearly as hot to cause that big of a boil over though. So we'll see what happens here in a couple minutes. And maybe I just overloaded it with too much acid. So me cutting back on it may help. I kind of want to get a video of it though, because this is new to me, and I haven't seen this method a lot on YouTube, so we'll see what happens. It'd be cool to know the limits, what not to do, and also what to do. So, awesome. Alright, just wanted to note, we got some condensation on the top now. I don't know if it's from the boiling. We've got a nice layer of bubbles coming up, so we've got a really nice reaction down there. The color has changed. It was kind of like white and cloudy, and it seems to be more like the similar look of copper nitrate now. It's not copper nitrate though. It's I actually couldn't even tell you what it is. Let's get temperatures on this. This is real life science. This is awesome. 88, so temperature is rising. Let me see here. Let me go down towards the base, towards the metal. Nothing. Let's see here. Oh, okay. Let's go right in the middle here. let's see, 89. We had 100 at one time. So the temperature is definitely up there. There it is, 100 degrees, 37, 36 Celsius. So we are getting up there. I could see this happening. It's very slow. It's a very slow process. Looks like we even have looks like the backside of a, backside of a copper, well, backside of a silver contact that still has a little copper on it. It's floating. Cool. And we're at, I want to say, the 20-minute mark right now. Alright, I'm just going to do a quick take the top off. I want to see what the bottom looks like. There we go. So it is really attacking. Okay, hold on. So with it off, we're getting more of a reaction. So I imagine it has something to do with outside oxygen. Just look at that. If I put that back down, it seems to, well, I can't say it seems to settle down, but there was definitely a much higher reaction with, oh yeah, here we go. It's coming now. Look at that. I added a little bit more oxygen in there. I'm going to add some distilled water, see if we can dilute that a little bit. There we go. Okay. Perfect. Cool it down. Look at that. Doesn't even work. Yeah, I'm thinking we're getting another boil over here. I took it down a little bit. But it seemed to have... we must use the oxygen out of the beaker, and there's not as much coming in. And when I introduced more oxygen, it really started to go. Yeah, because now look at 135. Oh, she's going over. She's going over. Let me get some more. That is crazy. Crazy. All right. Look at that. It's still going to go. I might pour that off so we don't have to clean up that mess. But, hey, I really wanted to record that. I really wanted to see it. Let's see here. We're about 450. So I want to say I doubled the amount of liquid we have in. We still have a good reaction going. 123. 51 degrees Celsius. I'm really flirting with danger now. We're right at the top of this beaker. Crazy. I never would have thought that that's what would happen. But I 100% believe it has something to do with me reintroducing the oxygen. So in this last one I had that I didn't have a cover on, so it was continuously open to the oxygen, the elements. And I imagine, you know, obviously there's a little space kind of where the spout is, but you know, I imagine there's a positive pressure in here, so we're not really getting oxygen in. We're more so releasing the fumes going out. And you know, with the top off, I bet you that, you know, I probably could have kept that if I didn't touch the top off of that. Might be another experiment if you want me to try. But I bet you if I didn't lift the top off of that, we would have been good to go. So we're still climbing up. We're about 131 degrees. 55 degrees Celsius. Almost 132. 131.9. It hasn't really moved yet, though. So my original thought stands. Man, hold on. I gotta get a good picture here. Look at it just attack those metals. Crazy. Alright, so I might have to try this solution with the thicker contacts now, because this is pretty incredible. I mean, this looks almost exactly like nitric acid on how it would attack metals. I mean, look at the bubbles in there. This stuff is hungry. There's no question about that. Oh, hold on. It's gonna happen. It's gonna happen. Let's see here. Still recording. I'm gonna pour some of this out. Yep, there she goes. She's starting to spew. Cool. Yeah, catch pan. Gotta have a catch pan. So I imagine, oh, hold on here, that that solution is still potent. Hey, look at that. I think we got her under control. Well, there's only one way to find out. We'll keep track of this, because this is interesting. Definitely change of pace here on the channel. All right, so I'm gonna have to say that this is fairly saturated at this point, and it's probably safe to go ahead and dump this off, and let's try it again. Let's see where we're at. We'll get a good inspection here. So let's see here. It looks like there's a couple of them that are free. So it looks like here we got a couple of them. So it's working. The stuff works good. So I think the stronger H2O2, hydrogen peroxide, basically just makes this reaction faster. I think that's all it does. Alright, so we're going to dilute it this time because I don't want to have to babysit it. So we're going to start with distilled water. Yeah, we'll do 200. Milliliters of hydrogen peroxide. That hydrogen peroxide, it goes already. I'm sure there's a little bit of that acid left. Let's see here. Citric acid. One tablespoon or a teaspoon. And the salt. We're going to try and do half a teaspoon. Rough guess. Rough guess. Half a teaspoon. Stir it all up. And let's see what happens. Alright, so I've got a couple of bolts here. We're just going to go ahead and set them in there and see if we can get any kind of copper cementation. See if we can pull that copper out of solution. This seems to be working pretty good. We're putting copper into solution and we don't have a crazy amount of reaction. So 12% might be a little much for this because it works really well like this. I mean, we did a video on this before. I guess the 12%, I can just put more distilled water in to dilute it, and it lasts longer. I don't know if that beats the value of the Dollar Tree stuff or the dollar store stuff, though. All right, let's get a good check on this here. Get my goggles on quick, my glasses. So I've been letting this stuff cement out for a little while. This is the solution that we use to eat up our copper and base metals from right here. So let's go ahead and pour this out. I'm going to kind of stir this up, hopefully to get some of those copper crystals in here. They seem to get absorbed in the solution and then cement out. So at least with what I was looking at before, I don't see any more of these crystals in. And you'll see what I'm talking about. There's kind of a base layer of copper crystals. Let's see here. And it's kind of firm, so you can see there how well it likes to hang on to stuff. So that kind of coats the entire beaker. So you can see we got just absolutely tons of that copper crystal back there. So let's give this a couple of rinses here, some distilled water. I actually might just try and boil this, see if we can't get these copper crystals to go in solution. Alright, on the heat blade it goes. Alright, so this has been boiling for, I don't know, probably a half hour, I'd have to say. And it is still not in solution. So I'm going to have to say that is, we could probably try hydrochloric acid. But in all honesty, the more acids I use, the cost of this project goes up. So I can just simply rinse them off and pour these crystals out. Keep the cost down. So we'll show you here in a minute. Let's see. I'm actually gonna scrape some of this off of there. Always got some good sounds for you. All right. I'm curious if this boil helped with the cleaning up the contacts a little bit. Like I said, these crystals are pretty sticky. A couple hard spots yet on the bottom. Alright, let's pour this off here. I'm just pouring it in here. Yep, tons of crystal left down there. Alright, I think I got the perfect solution for this. Actually, I lied. I'm not going to do that. Because I know it's going to happen. I'm going to miss, and they're going to go into my cement silver. Or cement copper, I mean. Alright, so clean my beaker out, and here we are. So I'm going to just put a little bit of hydrochloric in there now that I got most of the that copper crystal out of there. just so we can take a sneak peek. Hopefully that dissolves the that green copper. We'll find out here in a minute. Alright, let's let this sit here a little bit. See if we can get that copper in solution. It looks like that hydrochloric acid is getting a little darker. I'd say it's doing exactly what we want it to. Nice copper 2 solution, if that's the case. Oh yeah. So this hydrochloric acid isn't waste. We could reuse this for other goodies now, which I'll actually probably pour into a project I already got going on. We might not even have to fast forward this. I don't think so. Alright. Right into this back beaker. There we go. Well, I'm going to go ahead and clean these up, and I'll get back to you. And there you go. So we could let this go for a little longer, probably another batch or two, but I just want to show you how well this stuff works. It's really cheap. It's not a lot of harsh acids or harsh chemicals, besides the last rinse with the hydrochloric acid. Maybe we can look into, next time I do this, I'll finish this off, and then next time what we'll try to do is we'll try to use hydrogen peroxide, see if that cleans it up, and that would keep all the real harsh chemicals away. But yeah, we've eliminated quite a bit of that base metal. Sweet. All right. So hydrogen peroxide, salt, and citric acid. I really like this method. Now I think the 12% is a little much. I don't think it's worth the extra cost when you can get the 3% from the Dollar Tree or the dollar store or whatnot, and it works just as well. Matter of fact, I don't think it creates as much heat, so you don't have to worry about the boilovers as much, which is nice because then it's a little more set it and forget it, you know, which is what we're all about. I look a little tired. Let's see here. Look at that precious little thing. Sitting here making videos and got the best view. So back to our solution here. Those crystals, they're kind of a pain in the rear to deal with. Now, what I noticed while putting this video together is that when the solution was hot, and I poured it off when the solution was hot, I didn't have those crystals to worry about. So what I'm thinking that happens is that as the reaction occurs in the beaker, it heats up the solution as we witnessed, and when you got a hot solution, it's able to absorb more base metals, right? The molecules expand more, and you can fit more in there, and when they come crashing down, when the temperature comes down, the molecules go from working like this to working like this, and they got to spit the rest of those out, which is in the form of those copper crystals. And yeah, they get everywhere, and they get stuck on everything. So it's definitely best to pour them off when they're warm and not cold. Maybe set a timer. I've only done this a couple of times, so I got to figure out the exact, everything is different, but maybe set a timer or something.
I hope that's on the recording. That's awesome. And hold on, I gotta get my whole train of thought back. All right, well, train of thought's back. So maybe we get a timer set. After we play with this experiment a little bit more to see, how long the reaction exactly takes, and then you can still get there when it's warm, and not have to worry about those crystals at all. But if you let it sit overnight, not the end of the world. A little bit of hydrochloric acid cleans them right up. And in that process, I believe you're making copper 2 chloride, which is exactly what we try to make with AP. So acid, peroxide, hydrochloric acid, and hydrogen peroxide. So instead of adding the hydrogen peroxide to your hydrochloric, you can just add that copper 2 chloride that you made from this. So don't just put it in your stock pot. It's still valuable. And, you can use that for your legs or dissolving icy chip legs, not your physical legs. But, yeah, it's all good stuff. So thank you so much for watching, and I'll see you in the next one.